So in this particular question, we have a complex number 1 plus I. So we have to represent this complex number in the polar form. So let us do that. So first we assume that this complex number is z, which is 1 plus I. The first thing that we have to do is determine the value of r. So r is actually the absolute value of our complex number, which is the square root of the sum of squares. That means we first take the square root and then we square the real part, which is 1 squared, and add it to the square of the imaginary part, which is again 1 squared. So that gives us square root of 1 plus 1, which is 2. So this is going to be the value of r. Now that we have the value of r, we have to find out theta. Now before finding out the angle theta, so we'll first find out the value alpha. So alpha here is an acute angle which the complex number z makes with the positive x-axis, or we can say the x-axis simply. So this is equals to tangent inverse of the absolute value of the imaginary part, which is 1, divided by the real part, which is 1. So that gives us tangent inverse of 1. Now we know that the value of 1 is actually computed from tan pi by 4. So tan 45 degree gives us 1. So what we did, we just replaced 1 by tan pi by 4. So that gives us the alpha value equals to pi over 4. So now that we have the value of alpha, so we can find out the argument of the complex number g, which is theta, and that value is going to be equals to alpha. The reason being, since the real part of our complex number z is greater than 0 because its value is 1, and the imaginary part of our complex number z is also greater than 0. So that means when both the real part and the imaginary part are positive numbers, then our theta value is exactly equals to the acute angle alpha. So our value of theta is going to be pi over 4. So now that we have the two values r and theta, so our polar form, the polar form of the complex number z is given by z is equals to r times cosine of theta plus I times sine theta. So we have r here, so r value is square root of 2 multiplied by cosine of theta. So theta here will be pi over 4 plus I times sine pi over 4. So that's it. So this is how we represent the complex number 1 plus I in the polar form, and that is given by the square root of 2 times cosine pi by 4 plus I sine pi by 4. Let's do another problem. So here in this question we have a complex number -1 plus I, and we have to represent it in the polar form. So let us begin by first assuming that our complex number is given by z equals to -1 plus I. Then we'll find out the value of r, which is the absolute value of z, and that is the square root of the real part, which is -1 squared, added to the imaginary part, which is 1 squared, and that gives us square root of 2. Then we'll try to find out the acute angle alpha, which is the angle made by the complex number z with the real axis. So that value is given by the tangent inverse of the absolute value of imaginary part, which is 1, divided by -1. So that gives us simply tangent inverse of 1. Now we know that 10 pi by 4 is equals to 1, so we replace 1 by tangent of pi over 4. So let me write it down, since tangent of pi over 4 is equals to 1. So that gives us alpha is equals to, so tangent inverse of 10 function will simply go away, will nullify the effect of the tangent function by the inverse function, so that leaves us with pi over 4. Now we see that the real part of the complex number z is equals to -1, and this value is less than 0, while the imaginary part of the complex number is equals to 1 and this is greater than 0. So that means our complex number z lies in the second quadrant. So that being the case, so let's quickly check it out how this is happening. So we draw the argon plane. So we have the real axis, which is be the real part of z, and the imaginary axis, which is the imaginary part of z. So we have a complex number, so the real part is -1. So we have -1 here, and from there we have to go 1 unit along the positive imaginary direction. So we have 1 here, so this is +1. So we have a complex number z, -1 plus I, which lies in the second quadrant. So that gives us alpha. So this is the angle alpha, acute angle alpha, which the complex number z makes with the real axis. But we need to find out the value of theta. So theta is always measured measured in the counterclockwise fashion from the positive direction of the x-axis. So that means we have to subtract alpha from pi. So that means our angle theta is actually equals to pi minus alpha, which is pi over 4, and that gives us 3 pi over 4. So this is the value of our angle theta. Now that I have it, so in polar form we have our complex number z given by r. So r is √2 multiplied by cosine of theta, which is 3 pi over 4, plus I times sine 3 pi over 4. So this is the polar representation of the complex number -1 plus I. Let's move on to the next question. So here we have a complex number z given by -1 minus I. So we have to represent this complex number in the polar form. So we go the usual route. So we find out the value of r, which is going to be the square root of -1 squared plus the coefficient of I, which is -1 squared. So that gives us square root of 2. Then we'll find out the value of the acute angle alpha, which the complex number z makes with the real axis. So that will be tangent inverse of the absolute value of the imaginary part, which is -1, divided by the real part, which is also -1. So that gives us tangent inverse of 1. Likewise, in the previous example, we have tangent inverse of 1 is equals to pi over 4. Now we have the real part of our complex number z is -1, so that is less than 0, and the imaginary part of our complex number z is also -1, which is less than 0. So that means our given complex number z lies in the third quadrant. It lies in the third quadrant. So whenever a complex number lies in the third quadrant, then the argument of the complex number, which is theta, is given by the negative times of pi minus alpha. So we have negative times of pi minus pi over 4. So that gives us theta value as -3 pi over 4. So now that we have the value of both r and theta, so our polar representation will be z is equals to r cosine of theta plus I sine of theta. So we replace the value of r by square root of 2 multiplied by cosine of -3 pi over 4 plus I times sine -3 pi over 4. Now, the rule of trigonometry states that cosine of negative theta is equals to cosine of theta, and sine of negative theta is equals to negative sine of theta. Here The reason being that cosine of theta is an even function and sine of theta is an odd function. So we use this result, so that gives us z is equals to square root of 2 multiplied by, so cosine of negative 3 pi over 4 will simply become cosine of 3 pi over 4. We'll have negative I sine 3 pi over 4. So this is going to be the required polar form of the given complex number. Let's move on to the next question. So we have the complex number 1 minus I, and we have to represent it in the polar form. So we have z given by 1 minus I. So the r value is simply going to be equals to the square root of real part squared plus the imaginary part squared, which is going to give us the square root of 2. Then we find out the angle alpha, which is equals to tangent inverse of the absolute value of the imaginary part, which is negative 1, divided by the real part, which is 1. So this value is going to be equals to tangent inverse of 1. So that gives us tangent inverse of 1 is pi over 4. Now we have the real part of our complex number z is 1, which is greater than 0, and the imaginary part of our complex number z is equals to negative 1, which is less than 0. So our complex number z lies in the fourth quadrant. So that means our theta value is going to be simply equals to negative alpha. So that means we are measuring theta in the clockwise fashion. So this is equals to negative pi over 4. So in the polar form we have the value of z is equals to root 2 times cosine of negative pi over 4 plus I times sine negative pi over 4. So that finally gives us square root of 2 times cosine of negative theta is always positive. So we have cosine pi over 4, and sine of negative theta is minus of sine theta. So that gives us minus I sine pi by 4. So this is the polar representation of the complex number 1 minus I. Let's move on to the next question. So we have to express the given complex number in the polar form. So let us begin by considering that a complex number z is given by negative 3 root 2 plus I times positive 3 root 2. Then we find out the value of r, which is simply the modulus of z. So that gives us the real part, which is 3 root 2. We square it and then add it to the square of the imaginary part. So that is 3 root 2 squared. Now we have negative 3 root 2 squared, so that will be 3 squared is negative 3 squared is 9, and root 2 squared will be 2. So 9 times 2 is 18. Similarly, for 3 root 2 squared, we will have 18. So this gives us 18 plus 18 is 36. So the square root of 36 is 6. Now that we have the value of r, we'll find out the value of alpha. So alpha will be tangent inverse of the absolute value of the imaginary part divided by the real part. So that gives us alpha is equals to tangent inverse of the absolute value of negative 1. Since the absolute value is always positive, so this is equivalent to tangent inverse of 1. So tangent inverse of 1 gives us pi over 4. Now we check in which quadrant the given complex number z lies. So here we have the real part of a complex number z is equals to negative 3 root 2. So that means it's less than 0, while the imaginary part is 3 root 2, and this is a positive value. So that means that our complex number z lies in the second quadrant. So in the second quadrant, we have a negative real value and a positive imaginary value. So that means our theta value will be equals to pi minus alpha, which is equals to pi minus pi over 4. So that gives us 3 pi over 4. So now that we have the value of both r and theta, so we will have the final complex number in the polar form will be 6 multiplied to cosine of 3 pi over 4 plus I times sine 3 pi over 4. So this is the complex number in the polar form.